Okay, last example for this lesson. A game consists of rolling a die, one single die. If you roll a 1 or a 2, you win $5. Oh, looks like more winnings here. If you roll a 4, 5, or 6, ooh, you pay $1.25. Paying $1.25 means you lost $1.25. It doesn't say anything here about what it costs to play the game, so we have to assume that it does not cost anything to play this game. Okay, it's asking us for a distribution for the winnings. Well, that's pretty easy. It told us exactly what we had to figure out. Here is my x, here is my px, and here is my xpx. Probably we're going to need that in a second. So x, what if we rolled a 1 or a 2? We win $5, right? That's winnings. What's the probability of winning $5? Well, I've got a 1 or 2. That's 2 in 6 chance, or 1 in 3. Next, winnings. Well, what else could happen here? I could roll a 4, 5, or 6, and I'd have to pay $1.25. That's losing $1.25. So minus $1.25. And the probability of that happening, since there's 3 ways, is 3 in 6. Is there anything else here that could happen? Well, there is actually, because we could win how much money for rolling a 3? Does it say anything about rolling a 3 here? No? Okay. Well, then rolling a 3, which is a 1 in 6 chance, we end up with $0. Nothing happens. Didn't win, didn't lose. It's like a break even. Okay. Let's figure this out now. So xpx, remember, is multiplying this column x by that column p of x. 5 times 2 is 10, 10 and 6 here. Negative 1.25, times 3 is negative 3.75 out of 6. And 0 times 1 in 6 is 0 in 6. The sum of those 3 columns is 10 minus 3.75. which is 6.25 out of 6, or $1.04 per game. So the expected winnings for this game to the player is $1.04 per game. And I'm going to write to the player. Those are player winnings. So the next question always, for a question like that is expected value, would be, or my question to you would be, is this a fair game? Based on what you calculated now, what does this tell us about whether that's a fair game or not? And the answer to that is, if the player is making, on average, $1.04 every time they play the game, then no, this is not a fair game. Absolutely not. And why? The player is expected to make $1.04 per game, on average. That's not very fair to the dealer. So there would also be, most likely, a follow-up question to that, which is D. If you said it wasn't a fair game in C, which is fair enough, no pun intended, in D, how could you make it a fair game then? What could you do to make this fair? And the first thing we have to understand about that is, what is a fair game? So let's go to the very bottom in general. A game is considered fair if, and only if, the expected outcome is 0. It cannot favor the player, and it cannot favor the dealer. So what's the simplest way to make this a fair game? I think the easiest way to make it fair, you could change the rules and make sure that these actually even out, so that we don't get 6.25 here, but instead we get 0. That's one way to make this fair. But also you could say, to make it fair, the dealer needs to charge $1.04 per game. then everything evens out. So if the dealer is charging the player $1.04 to play, and the player is making $1.04 every time they play the game, well then that balances each other out. Now that's kind of a silly thing to do, because who's going to pay $1.04 every game? But that's the easiest way to change this. If you want to take a crack at figuring out how to change the rules of this game, it's not that hard. You can change the rules so that this numerator ends up being 0. That's a different way to figure this out. So just quickly to recap, in general, the expected outcome is referred to as E of x, not P of x, but E of x, and it's when you add up all of these xpx's that we were talking about all throughout this lesson. When you figure out x times px, that's the weighted average, and you add them up, you get the expected value for that outcome. In a uniform distribution, the probability is always 1 over n, where n is the number of possible outcomes. For example, if you roll a single die, there are 6 outcomes, 1 through 6. What's the probability of each? 1 over 6. If you flip a coin, there are 2 outcomes. The probability of each outcome is 1 and 2, etc. And we already talked about this, but a game is considered fair if the expected outcome is 0. Okay, good luck with your homework. I will try and post that on the classroom. Make sure that you have practiced this throughout the week, and I will be back in touch later on in the week for your next lesson. Thanks all.